Okay, here we go. As we know, the capability of network components has been evolved over decades. About more than 5 years, this 1.2 gigahertz upgrade started, and now we are entering the new area. The new 1.8 gigahertz wave is starting. There are several ways to do such a network upgrade. And here are some examples. Already Jan presented those. At first, it's just increasing the gain of those amplifiers. Obviously, those amplifiers have a high gain, high performance, and in very many cases, those are equipped with sophisticated features. The second one is that using the high gain amplifiers again, but as Jan mentioned, adding the booster, low gain amplifier in between, where the need of total gain is way too much, and this booster is increasing the needed requirement of that. This kind of mixed gain architecture concept has been used in some 1.2 gigahertz upgrades in past already. Or break the whole network and multiply those with a very low gain amplifier. The performance of these amplifiers is moderate, but the number of amplifiers is doubled or even 2.5 times compared to starting point. In past, many way upgrade has done with the unity gain principle, meaning that amplifier includes some gain reserve for the alignment and also automatic level regulation. In that way that the network and upgrade is easy to plan, and those levels will be transferred easily to the field later on from the design table. I see that such an output regulation is needed even with the low gain amplifier architecture. Of course, when we are talking about high gain amplifiers with the high gain and high performance, the total loading will be the limiting factor in that case. However, there is possibilities to relieve that problem by step down the highest frequencies. And picture in here, I show that what is the loading reduction and what is the effect for the theoretical data capability. This is not, of course, this is not the same as a throughput. This is theoretical maximum for the pipe itself, but the throughput has an additional reduction because of the overhead needed. But anyway, all loadings are feasible to keep that 10G maximum speed promise. Then what about the network upgrade and this 1.8 gigahertz upgrades itself? So there are many things that you have to consider in that project and plans, and this is try to illustrate what would look like. What is the capacity demands? What is the planning parameters? How you want to implement this upgrade, and what are the what are the ways that you want to operate that network after the upgrade. So that problem field is now divided here to the three components, three different components, and in operational point of view, then the questions are: what is the total power consumption? What already Jan expressed in his presentation. In top of that, what is the power feeding locations? Do those amplifiers have a reserve for the automatic level regulation, and etc.? What is the number of elements? If you have already tens of thousands elements in amplifiers in your network, what is the effect if you want to multiply that one? What is the effect for the maintenance or troubleshooting perspective? Or even, are those elements amplifiers, do you want to, how you monitor those devices, if any? Then about the execution and implementing the upgrade, the questions are that, what about the legacy infrastructure? Do we want to utilize those existing amplifier locations? Do we want to utilize existing power feed locations? Is there easy access to the cables if the new additional amplifier or element has to be implemented there? So, and cable cut is must. How flexible those amplifiers can be located, how flexible amplifiers are designed that you can select several locations or window of locations where you can put that one. And in those amplifiers, has their reserve of gain that you can utilize the unity gain principle for the alignment, and what to do with the RF passives. Those are the questions where what are crucial when you are planning the upgrade. And about the planning the upgrade, the planning and such details what are meant to be for the upgrade itself, and in operation, planning and details, those are linked to each other and vice versa. And about the planning rules and selections of what kind of details you want to use, obviously those will affect that what are the loadings, what kind of amplifiers you can want to use there, what are the most important are, what are the levels on the home premises, and what is the system performance. Levels and performance will tell what is the capacity, system possible capacity that you can deliver to the end subscriber. As said, details are linked, and every selection is a compromising the thing, and details are linked to each other. But all cases, all the time, the focus will be that this 10G top speed promise must be achievable for the subscriber. And it's not easy to play inside this trouble field. And as I said, and I would say that it is always balancing such features, the parameters, and exact optimum do not exist. It's about the compromise, and then this is this three field figure try to describe that what kind of compromise we are talking about? We are talking about network level. What are the performance? What is the maximum theoretical performance? What is the practical performance, needed performance for the network? How easy that is plan, make the upgrade, and also how easy that network is operate after the upgrade, and obviously how much that cost. What is the total cost of the planning, executing the upgrade, and operate the network? Those are, in my opinion, three important points, and then it's question of the how you want to balance in this field. I described in the beginning of my presentation these three possible ways to make the network upgrade. Three possible concepts, and if we take assumption in that way that high gain amplifiers are very sophisticated features and low gain amplifiers are very simplified, then we would the end result like this. With the low gain amplifier, it's true that you can get best performance. That's no question about that. How easy is the planning, making the integration, and operating those networks? Those are then the mixed gain amplifiers, high gain amplifier architectures on that side. But as I said, every detail matters, and every detail will affect to every other parameters, and it's a question that what feature or goal you want to optimize, then the end result in this kind of mapping is totally different. But when we are talking about the upgrade, 1.8 gigahertz upgrade, the main question is, what is the parameter to optimize? What are those parameters you want to optimize in your network? Okay, as my summary of this presentation, I want to underline a couple things. This 1.8 gigahertz upgrade wave, that is coming, that is in horizon. We are in the starting point of that one. This 10G maximum speed promise, that is feasible to achieve with many ways, with many concepts. There is no one and only solution for doing that. And what is important, detailed planning is needed, and some planning rule decisions has to be made. And then it is question that what are the features, what the operator want to optimize in that work. And then the question where we are in this field of 1.8 gigahertz. With Teleste, we have studied this area, this 1.8 gigahertz technology now more than 2 years. And it has been tested, and results are showing that what are the restrictions of system level, what are the limitations in each architectures. And now it's time to discuss with the operators, and we have discussing with many operators about these details, how these upgrades are possible to do. And during this year, we are closing these discussions, and some decisions can be made, and plans can be start to finalize. We can finalize our amplifier design, and also component manufacturers can start to finalize the components. So everything will be ready for the 22 to build up such a gear, then end of next year, those upgrades are ready to rock. Okay, thank you for your time. And this was short presentation with we could spend hours in the details, but and you can freely contact me if you want to spend a couple hours in these upgrade details. Thank you.